This video deals with graphs of another new function. It's the graphs of a function known as the hyperbola, and we're going to look at particular rectangular hyperbolas, and they're ones that have a basic equation of y equals 1 over x. In this video we're going to deal with plotting these types of functions. Next year in Methods Unit 1 and 2 we'll actually look at sketching them and some more in-depth transformations. So the first function we're going to plot is y equals 1 on x, and we've got a plot box from -4 up to 4. So I'm going to fill in the values. So when x is equal to -4, y is equal to -1 over 4. So we'd fill in -1/4. So when x is equal to -2, it'll be -1/2. When x is equal to -1, y would equal -1 as well. When x is equal to -1/2, it'll be 1 over -1/2, which will come out to be -2. Using the same sort of logic for -1/4, that'd be -4. The next one we come across is when x is equal to 0, y is equal to 1 over 0, and this is undefined. Which means that x equals 0 is not allowed, which means that when we go to sketch the graph there'll be an asymptote at x equals 0. A quarter would be +4, x equals 1/2 would be 2, 1 is 1, x equals 2 is 1/2, x equals 4 is 1/4. The other thing that we may need to consider is there's an asymptote at x equals 0, and that's the vertical asymptote, but there'll also be a horizontal asymptote at y is equal to 0, and we'll have a look at why that might be the case. When y is equal to 0, we get 0 is equal to 1 over x. So then we get we take the reciprocal of both sides, so we get 1 over 0 on this side is equal to x over 1. So we get y is equal to 1 over 0, sorry, x is equal to 1 over 0, and that's undefined. So there's an asymptote at x equals 0, there's also an asymptote at y equals 0. And for basic graphs that haven't been shifted left, right or up and down, there'll always be an asymptote at x equals 0 and y equals 0. So now we're going to plot the points for y equals 1 over x. So when x was equal to -4, y was equal to -1/4, so that'll be about there. When x was equal to -2, y was equal to -1/2. When x equaled -1, y equaled 1. When x equaled 1/2, y was equal to 2. Sorry, -1/2, -2. When x equaled -1/4, y was equal to -4. Now if we go over the other side, we know that x equals 0 is an asymptote. We also know that y is equal to 0 is an asymptote. But when x was equal to 1/4, y was equal to 4. When x was equal to 1/2, y was equal to 2. When x was equal to 1, y equaled 1. When x equaled 2, y equaled 1/2. And when x equaled 4, y equals 1/4. So the graph of a hyperbola has two parts, and those two parts are separated by the asymptotes. So just some general rules about hyperbolas. All hyperbolas will have a vertical and a horizontal asymptote. A rectangular hyperbola is the graph of the rule y equals a over x, and a can't equal 0. if you go on to look at General Maths A or Specialist Maths, you may come across different types, or you will come across different types of hyperbolas. Y equals 1 on x is the basic rectangular hyperbola, and for this one, x equals 0 and y equals 0 are its asymptotes. If we have an a value that's greater than 1, the hyperbola will move further out from the asymptote, so it won't go quite so close. And if it's a value between 0 and 1a, the hyperbola will then move closer in towards the asymptotes. And both of these are using y equals 1 on x as a reference point. So if we have a look at the graphs that we've got here, the full red line is y equals 2 over x. The dotted red line is y equals 1 over x, and the blue line, the solid blue line, is y equals 1/3 x. And we can see that the 2 over x is further away from the x and y axis, which act as our asymptotes. The 1 over 3x is much closer to the x and y axes. The graph of y equals minus a over x is just a reflection of the graph of y equals a over x about the x or y axis. So if we think about it, this part of the graph that's up here will reflect down here. This part of the graph that's here will reflect up here. So now we're going to do example 2. We're going to complete the table below and then plot the points on the set of axes for the hyperbola with the rule y equals minus 2 over x. So minus 2 over x divided by minus 4 when x equals minus 4. So that'll be minus 2 divided by minus 4, so that'll be positive 1/2. Then we've got minus 2 over minus 3, so that'll be positive 2/3. Minus 2 over minus 2 would be 1. Minus 2 over minus 1 would be 2. 2 over 0 would be undefined again, so we know x equals 0 and y equals 0 are asymptotes. X equals 1, so y would equal minus 2. X equals 2, so y would equal minus 1. When x equals 3, y equals minus 2/3. And when x equals 4, y equals minus 1/2. So if we set up our axes to draw the graph of y equals minus 2 over x, we know that we have asymptotes along the x and y axes. So the one on the y-axis will be at x equals 0. The one along the x-axis will be at y is equal to 0. And then we're going to plot some points. So at minus 4, x was equal to positive 1/2. At minus 3, x was equal to 2/3. At minus 2, it was equal to 1, and at minus 1, y was equal to 2. So there's 1/2 of our graph. We know that at x equals 0, we have no value for y. When x was equal to 1, y was equal to minus 2. At 2, it was equal to minus 1, minus 2/3, and 1/2, and we can see the second half of our graph. And there's a graph of y equals minus 2x, and we can see that it's been reflected about the x-axis, and also it's further away from the x and y axes than a normal graph of y equals 1 on x. Okay, so our last example is a slightly more complex function. Instead of just being a number over x, we've got 1 over x plus 1. So when we want to plot our points, when x is equal to minus 4, y will equal 1 over minus 4 plus 1. So y will in fact equal minus 1/3. When x equals minus 3, it'll be 1 over minus 3 plus 1, so it'll be minus 1/2. 1 over minus 2 plus 1 will be minus 1. This is where it's interesting. When we put x equals minus 1 in, we get y is equal to 1 over minus 1 plus 1, which equals 1 over 0. So we know that's undefined. So we now have an x asymptote at x equals minus 1. Our y asymptote will still be at y equals 0. So there's no value at x equals minus 1, but when x is equal to 0, y is equal to 1 over 0 plus 1, so it'll be 1. When x is equal to 1, y will equal a half, a third, a quarter, and a fifth for the remaining values. Okay, so we've set our axes up. Because the highest value is 1 for the y values and the lowest value is a fifth, I've broken it up into quarters so that it'll be easier to plot. I'm going to put in my asymptotes first of all, and the first asymptote is going to be at x is equal to minus 1, and then y is equal to 0 will be our other asymptote. It's a positive graph. So now I'm going to plot some points. When x was equal to minus 4, y was equal to minus a third. So minus a third is slightly bigger than minus a quarter, so we'll put the point there. When x was equal to minus 3, y was equal to minus a half. When x was equal to minus 2, y was equal to minus 1. There's 1/2 of our graph. Now we've got a value when x is equal to 0, y is equal to 1. And we know that corresponds to our x-intercept. When x was equal to 1, y is equal to a half. When x is equal to 2, y is equal to a third. When x equals 3, y equals a quarter. And when x equals 4, y equals 1/5. So that's a graph of y equals 1 over x plus 1. That concludes the video on plotting hyperbolas. Be sure to attempt all questions in the relevant task, and if you are unsure of anything, please check back with your teacher. Good luck.